Welcome back, Innovators. It's fantastic to have you here for another Idea Mechanics Explainer. Today, we're unpacking a literally game-changing concept from TRIZ. That's the theory of inventive problem solving, for those joining us for the first time. And as always, guiding us through the digital lab today is our lead innovation catalyst. You can see him right over there on the screen in his signature red shirt and glasses. He's going to help us bridge that gap between abstract theory and actual practical execution. So let's jump right in, shall we?
Just look at what our navigator is pointing to right now. Stop relying on luck and start mastering systematic discovery. I absolutely love that. So if you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next.
All right, here is our blueprint for today's explainer. We'll be covering systematic discovery, the loading screen trap, velocity as physical protection, and finally, zero-weight digital intelligence. Section 1. Systematic discovery, abandoning the guessing game.
You know, there's this really common myth in the tech world that great breakthroughs are just random sparks of genius, a magical eureka moment. But let's be real, relying on a lightning strike is definitely not a strategy. As our lead expert is showing us here, systematic discovery is a highly structured, repeatable discipline. It means we are directly solving everyday industry contradictions, moving completely away from that painful trial and error phase. TRIZ actually gives us a reliable methodology to architect solutions on demand. It's about engineering the outcome, not just crossing our fingers and hoping for it.
Moving on to Section 2, the loading screen trap, the digital bottleneck.
Okay, so the primary contradiction software architects face today is, how do we deliver deep, data-heavy experiences without creating a massive, annoying bottleneck? The old way of doing things is what we call reactive latency. That's basically accepting slow processing as just the inevitable cost of complex analysis. Throwing up a loading spinner and just hoping the user stays. But the TRIZ way? Utilizing Principle 21 asks a much better question. How can we use high-speed processing not just as a cool feature, but as a deliberate protective measure to ensure our product's integrity?
Section 3. Velocity as physical protection, anchoring the metaphor.
To really solve a digital contradiction, we first need to look at how physical forces are conquered in the real world, like in the medical and manufacturing fields. Take a look at this breakdown. In dentistry, cutting slowly actually causes tissue necrosis. The protection? High-speed drills. In eye surgery, slow lasers cause thermal damage, so they use nanosecond pulses instead. And over in the plastics industry, slow cutting causes the material to melt and warp. The solution there is high-speed cutting. See the pattern? In all these industries, physical friction is mitigated by rushing through the process so incredibly fast that the damage simply cannot manifest. In these cases, time is literally the enemy. Let's zoom in on medical velocity for a second. When a dentist uses a high-speed drill, the cutting action is completed so rapidly that heat literally doesn't even have time to build up. This is absolutely crucial because it prevents pain and protects those delicate biological structures. And the exact same logic applies to modern excimer lasers used in LASIK eye surgery. They operate with extremely short, high-energy pulses that last just nanoseconds. This ablates the tissue with minimal heat transfer. So the speed itself is the ultimate medical safeguard.
We see this exact same principle at play in manufacturing too. When you're working with thermoplastics, friction from a slow cutting tool can completely ruin the product. But by cutting the plastic faster than the heat can spread, manufacturers achieve perfect, precise cuts without any deformation at all. They are deliberately skipping that prolonged exposure that causes the material to fail.
Which brings us to Section 4, zero-weight digital intelligence, the software translation.
All right, now let's map this physical metaphor directly into your software architecture. In physical systems, as we just saw, friction and heat cause material deformation and biological trauma. In digital systems, well, the heat is latency. If a process takes too long, that friction manifests as user frustration. It causes drop-offs and totally ruins the digital experience. We have to protect the user from time exactly the same way a surgeon protects a patient from heat.
And this brings us to the core concept, zero-weight intelligence. What this means is optimizing your algorithms and leveraging high-performance computing to process massive amounts of data in real time. We are completely bypassing user wait times. You see, algorithmic speed is no longer just a nice-to-have performance metric. It is a structural safeguard for the user experience. You are rushing through computational tasks specifically to protect the user from the harm of waiting.
Think about personalized recommendation systems. They perfectly embody TRIZ Principle 21. First, they ingest massive amounts of behavioral data. Second, they rush through that data analysis using incredibly sophisticated, high-speed algorithms. And third, they deliver personalized recommendations instantly. The system completely resolves the contradiction between heavy data analysis and instant delivery by just skipping the delay entirely.
So to synthesize our main takeaway here, mastering real-time performance is a highly repeatable architectural skill. Rushing through computation is a protective measure. It eliminates those painful analysis delays and creates a seamless, engaging user experience. In fast-paced industries like e-commerce and streaming, this zero-wait intelligence is exactly what drives user retention. Engineer the latency out, and you protect both your software's integrity and your overall business model.
I really want to leave you with this provocative thought to apply to your current projects. How can you apply skipping to completely bypass the biggest latency bottleneck in your own software architecture? Don't just accept the delay, engineer it out. You now have the systematic mindset to do exactly that. Drop your thoughts in the comments below so we can keep building this culture of innovation together. Until next time, keep architecting brilliance.